Arithmetic sequences just have a common difference, d, and it could be positive or negative. It doesn't have to be a whole number. So arithmetic sequences have a common difference. We call it d. With geometric sequences, they have a common ratio. We call it r. And arithmetic means is just the average. It's the missing terms between two other terms in an arithmetic sequence. So you could just write average. Arithmetic means is the average as you know it. Like you took 3 tests. You add them up, divide by 3. That is an arithmetic mean. And when you add them up and divide by however many there are. So a couple things that we'll want to be sure we can do. One is model the arithmetic sequences with explicit or recursive formulas. So we need to know how the formula works, how to use the formula to find the 30th term of a sequence, arithmetic sequence or whatever. Use the formula later, Gauss's formula. You probably heard the story of Gauss. We'll talk about that, but that gives us the sum of an arithmetic series. All right, so the arithmetic sequence formula, we've got a sub n equals a sub 1, where a sub 1 is the first term in the sequence, plus n minus 1, where n is the number of terms, times d, where d is the common difference. So that's our formula. So if I said find the 8th term of the arithmetic sequence, you would use that formula. So we've got a couple different ways of representing arithmetic sequences. One is recursive. That's this first one here. First one is recursive. It starts at 3. The second term would be 3 minus 4, right? So 3 minus 4 is -1, and then the next one would be -5, yeah. And then -9, ... So it's just telling us to take the previous term, starting at 3, and subtract 4 from it. So this one's definitely arithmetic. You can see. If a sequence is arithmetic, you should be able to identify a common difference. Do you see a common difference here? What is it? 1.7, -1.7. Yeah. And it is negative. It's going down, subtracting each time. So this is arithmetic based on the fact that it has a common difference. Okay. Both of those are arithmetic. All right, we're going to find the 150th term. We'll do that one together, and I'll have you try the one below it when you're in. Just using that formula. The formula, we'll write it down here again. A sub n equals a sub 1 plus n minus 1 times d. I'll just write it down. It'll help us to write it down and help you remember it. So it says take the first term, so a of 150, a sub 150 equals the first term 2 plus 150 minus 1 times the difference. And the difference we get by looking at the pattern in the sequence is 2. So the 150th term, rather than counting, on your fingers, for 15 finger sets, we can use the formula to get it. And what do you get? What do you think the 150th term is going to be? 300, yeah. Which, yeah, those are just even numbers. So, yeah, 150th term is going to be 300. It's doubling. It's going up by 2 each time. Go ahead and see if you can find the 46th term of the next one. So, see if you can find the 46th term of the next one. Do it and then check with the person next to you. So, using that formula, find the 46th term. Okay, good. All right, what you guys get? Negative 93. Negative 93. All right. Using this formula, we should be able to use this formula to solve for any variable in it, really. In this case, we're going to solve for d. It says find d if a sub 1 equals 10. So I'd pop in 10 for a sub 1. And then it says a sub 6 equals negative 30. So I put a negative 30 in here. And 6 in for n. And that just leaves d to solve for. So this principle, you got to be able to solve for a sub 1 or for n as well. So if we solve this for d, so we get d equals negative 8. You could check it. Starting at 10, if you keep subtracting 8, will you end up at negative 30? And that's literally what we're doing. Starting at 10, next one would be 2, and the next one would be negative 6, negative 14, negative 22, and then negative 30. Is that the sixth term? There's 1, 2, 3, 4, 5, 6. Yep. So the difference is negative 8. Keep subtracting negative 8 from the previous term, you'll land at negative 30 for the sixth term. All right. Pretty easy formula to use. It's just a linear formula. All right, it says find a sub 22 if a sub 3 equals negative 5 and a sub 9 equals 37. So there's a little bit of a difference here. There's probably different ways to do this. But let's write down the formula, write in what we know. Here we've got, it says find a sub 22. So we're going to find a sub 22. And what we know is we know what a sub 3 is, and we know what a sub 9 is. Let's go ahead and write this in. A sub 1 plus n minus 1 times d. We know n would be 22, so actually I could replace that with 22. We don't know enough information on this one to go and directly solve it. We need a sub 1 and we need d. So any ideas on how can we get a sub 1?
To do what we did in the last problem to find d.
Could. We'd have to use what we have here. That will work. Sure. So let's go ahead and find d. Let's start there. So here's what we have. A sub 9, I'll just write down the formula first. We'll have to think about how we can adjust this formula a little bit. And you could do it probably without the formula too. But a sub 9 equals, if I call this my a sub 1, basically the third term is like my a sub 1. So if a sub 9 equals a sub 3 plus, this would be n minus 1. We'll talk about what n is, times d. So a sub 9 would be 37, right? A sub 3 would be negative 5. So it's like I'm adjusting the formula and pretending that a sub 3 is like my first term. But if I pretend a sub 3 is my first term, now what is my n here? It's not 9. Well, let's count here. We start at a sub 3, a sub 4, a sub 5, a sub 6, a sub 7, a sub 8, a sub 9. I count 7. We could probably generalize this. Actually, we can. If I go from term 3 to term 9, it's always going to be the difference of those 2 plus 1. Okay, so it's going to be 7 here times d. Now, the other way we could go about this is using that idea of arithmetic means. And you could probably start, finding different terms and fill in the gaps with an arithmetic sequence. It's not bad. And then you can figure out the difference that way. But probably this is the most efficient way, just to use the formula, but adjust it so that it's like now these are your first and last terms. And then adjust n. Does that make sense, the adjustment of n? Okay. So solve that for d. Let me know what you get, and then we'll plug it back in up here. Back up here. What'd you get? It is 7. Yes, 7 works. So d equals 7. Okay, so now that we know d, I think we've got what we need here. We've got this becomes 21 times 7. So 22 minus 1 is 21 times 7. What about a sub 1? If I know d is 7, there's a sub 1. There's a sub 2. A sub 3 is negative 5. So if I work backwards, right, this would be negative 12 and then negative 19. So a sub 1 is going to be negative 19. So there it is. And so the two-step process here, then we can find the 22nd term of this sequence. This is one way to do it. What do you get?
How did you find a sub 1?
A sub 3 was negative 5. If I know the difference is 7 here. Let's see, am I going the right way? Yeah, adding 7 each time. So then I'm just going to subtract 7 back twice. So subtracting 7 once will give me a sub 2. Subtracting 7 from that will give me a sub 1. So what do you get for a sub 22? What is it? 128? Okay. So there it is. That's about as hard as the problems get in the problem set. Something like that. We're going to have to do a two-stager. All right, which term of the sequence, they give you the sequence here, is negative 500? Which term of the sequence? So what do they ask you to solve for in the formula this time? Is it 21? So let's write down our formula. A sub n equals a sub 1 plus n minus 1 times d. We know a sub 1 is 6. We know d is, it is negative. Negative what? 11, yeah. Negative 11. It's going down by 11 each time. And then a sub n is actually a sub whatever the n is here. We're going to call it negative 500. We're treating negative 500 like it's the last term in it. So let's put negative 500 in there. And then go ahead and solve that for n this time. And you'll find out what term in the sequence negative 500 is. So subtract 6 maybe, and then divide by negative 11. You should get a whole number. Then add 1 to it. What do you get for n? Negative 506 divided by negative 11. Add 1.
47?
Yeah, I think so. Do we have 47? Just wait. Earlier, he's already piped in. You just didn't hear him. Pretty much, yeah, no, carried us through one of the problems already. All right. Can you find the arithmetic mean between 132 and 98?
What's that mean?
Average. Right, average. We're just trying to show off your big math. Right? Yeah. There you go.
English. How do you do that?
You find the average.
Put them together.
Add them together and divide by 2.
Well, there's one missing.
So yeah, we're gonna find this. Add them together and divide by 2. What do you guys get? 115. Super easy to do, right? Once we know what arithmetic mean means. What about this? How would you do this? 2. What's that? How would you find the 3 arithmetic means in between these? Really, what we're asking you to do is fill in the blanks of the arithmetic sequence. Okay, you're going to set up algebraically, sure. Okay. Could we find this term in the same way we...
You find the mean of the middle term, then you find...
Yeah, you can do that. Yeah, you can do that. So add these up, you get 4. Divide by 2, you get 2. Where's that going to go? In the middle. And then it's just like this over. So and then halfway in between these two is. When it's arithmetic, I mean, you could use kind of a guess and check process until you find a common difference. Is this 5? Yep, it is 5. Negative 5, yeah. And then this one is going to be, now we've got the pattern, right? Yeah, it's 9. So add the absolute values of the first and last term. So 28 divided by 4 to get the D. Yeah. So did you guys hear that? Adding the absolute values of the first and last terms and then dividing by, you're talking about like the distance. So you got a 1, 2, 3, 4. Yeah. And divide it, because absolute value is distance. That would work. But however you want to do that, what I want you to be able to do is understand how you would get the next term in the pattern, how you fill in the blanks, how you find the nth term. And then eventually today here, we're headed towards how you get the sum of all of them. So write an explicit formula for, So explicit formula means a sub n equals, and then we're going to reduce this down if we can. I'm going to show you a connection here. So it's a sub n equals the first term, just 2, plus n minus 1. We got to leave it n minus 1 because it's an infinite arithmetic sequence. It just keeps going up, times d, which is 3. So that's the formula explicitly. I'm going to go ahead and simplify this. 2 plus, this would be 3n minus 3, or a sub n equals negative 1 plus 3n. Let me write it this way. A sub n equals 3n minus 1, which should look very, what's up?
We have to test what you do to do that.
Not necessarily, but what you're going to be asked to do here, this kind of connects to this number 75. 75 was an equation in sigma notation or summation notation for an arithmetic sequence of that nature. You see how this 5k plus 3 looks just like the 3n minus 1? It's of the form mx plus b. So an arithmetic sequence has as its number or sequence generator a linear equation of the form mx plus b. Okay, where the slope is the difference. Okay, that's important to understand, because the format in which you're going to see it as you move on in math is this, with the sigma notation like you saw in homework. You're going to be asked to find the sum of the series, of the arithmetic series. So, the one next to it would work pretty similarly to that. Could we write a recursive formula for this one right here? We wrote an explicit one. Could you do a recursive one where you have a sub 1 equals and then a sub n equals a sub n minus 1 plus or minus something? What's a sub 1 here? 2. What do you do to the 2 to get to the next term recursively? Add 3. So that's what it would look like recursively. You'll see a little fancy bracket there. So there it is, just for that one. But you should be able to write an explicit formula for an arithmetic sequence and understand the connection between that and a linear function. All right, so we're going to now move into series, talking about series next. So where a sequence is a pattern of numbers separated by commas, a series is a sum of the numbers of that sequence. So you'll have plus signs in between them instead of commas. So a series is a sum. So once again, a sequence is a pattern of numbers. You actually already wrote that down in the first page, but a pattern of numbers separated by commas. That was 12.1, I think. A series, this is the new part, is a sum of a certain number of terms in a sequence. We're going to be asked to find the sums of some finite series, arithmetic series. Finite just means there's a first and last term, like on this problem from the homework. There's a first term and a last term was the 20th term. So that would be a finite series. And then an infinite series would be one that continues forever. We're not going to find the sum of an infinite arithmetic series. But we will do that with geometric series. Ones that converge. You remember convergence and divergence? No. Well, we'll wait for next week for that. So the infinite series will have end in dot, dot, dot. The finite series will have a final term. So we're going to find the sum. What kind of series is this? Or
That would be finite.
it is finite. It ends at 99. And what type is it? Your types are arithmetic, geometric, or neither.
I think
Arithmetic, yeah. Did we talk about... Oh, no, I skipped a page. Sorry. You should have all these formulas on there. Do they show up on there already?
Yeah.
Okay. So the one we just were talking about for finding the nth term of an arithmetic sequence, here it is in sigma notation. And what I just showed you is if you take this formula up here and reduce it down, you'll end up with something like 5k plus 3, or we had 3n minus 1. That's usually how they'll have it written. We usually have it written just in like mx plus b form here. And then an arithmetic series. Now this comes from that story that you've been told before, where at age 9, Gauss was misbehaving.
Mr. Cash?
Mr. Gauss. Lived a little bit before Mr. Gauss. Just a few hundred years before Mr. Gauss. But misbehaving like Zach does sometimes when he's not in the front row. But misbehaving, he was age 9. But his teacher, as punishment, rather than writing sentences, which must have been a math person, but said, you need to add up the first 100 counting them. And Gauss had the answer, 5,050, just like that. But what Gauss did in his head, and formalized later here, is he just took the first term, which was 1, the last term, which was 100, and said, well, 1 and 100 add up to 101, right? And how many pairs of 101 do I have? 50 of them, right? And so 50 times 101. But that's what's at the core of this formula, and it'll work starting at any point. It just says it doesn't have to be just 1 to 100. That would be an arithmetic sequence going up by 1s, a very boring D. But it can be applied to, something like this, where we have a finite sum. Now it only works for the finite sum. Okay, we have to know the beginning and ending, first and last term. But here it is. This one's going up by 5s, but we've got a first term of 4, a last term of 99, and then we have to somehow figure out how many terms are in there, because that's going to make a difference. Because otherwise we don't know how many pairs of 103 we have in there. So let's write down our formula. It's S sub n equals n over 2, and then it's a sub 1 plus a sub n. I need to somehow figure out what n is. How am I going to do that?
Math.
Yes. Which math? That's kind of broad. What's that?
Divide the difference by, or you subtract 4 from 99 divided by the difference of 5.
Okay. Yeah. And that's coming. Yes, you're right. And that's coming from this formula. So for those of you who kind of want to see what's going on in Wyatt's head there, we've got this formula, right? For finding the nth term, and that's what you're doing. And to find n, we know the difference is 5. We know the first term is 4. We know the last term is 99. So what Wyatt said is find the difference between these two. Yeah, that's what we're doing here algebraically, and then divide by 5, and then add 1. Put the add 1 in there. We would have to add 1. So 95 divided by 5 is 19, plus 1 is 20. So what we find out here is that there are 20 terms in this thing. So we've got S sub 20 equals 20 over 2, 4 plus 99. But we've got, 10 pairs here. And you can do some counting to figure out how many pairs and avoid the formula. It's okay. But you have 10 pairs that add up to 103. That makes it easy, right? 10 pairs that add up to 103, so we've got equals 103 and place another 0 on them, we've got our sum. This next sequence or series is actually an infinite series, but we're going to cut it off at 258. So we can find the sum of the first 258 terms here. We have S sub 258. Oh, this thing's messing up on me here. Slow down here. No. Oh, no. It's a bummer because I'm trying to record it. That's going to be a problem. So you would take S sub 258, if I give it a minute. Just pause. Have a pause. It's like for students. And they get caught out. That's what it looks like maybe in your brain sometimes as I'm going. It just starts glitching and things go. Start adding. There you go. Why don't you work on that? Yeah. Well,
Imagine just saying,
oh, there it goes. That's a 258 equals. So it'll be 258. Oh, come on, it could do it here. First term is 1 plus last term. There it is in crazy writing. So in hieroglyphics, we have S of 258 equals 258 over 2. There it goes. It's back. It's glitchy here. 258 over 2, 1 plus, but I need to know what to put in here. So now I go to my other formula. A sub 258 equals 1 plus n minus 1 times the d is 2. The n is 258. And I can't read it. This is awesome for the recording. So those of you out there trying to watch the recording, good luck on seeing what's going on. Yeah, recording all this. So 258 minus 1, there it goes, it's back, times 2. So what do we get here? 2 times 257? I don't know. That's why I have you. 514. 514 plus 1 is 515. So there it is. Fill in the blanks. And that's literally what I'll do with these formulas. Just go, okay, now what do I need to be able to find out what I'm looking for? So the sum of the first 258 terms is what? We got 258 over 2. What do you get? It's a large number. A lot of terms. 66,500 and what?
64.
Okay, there it is.
Eric.
I'm trying to do it.
Never mind.
He's what term are you on right now?
I don't know.
Yeah, are you up to 30 terms yet? Just don't hit the wrong button.
Eric hit the one.
Eric, did you hit the wrong button?
All right. We're just going to do a couple of these. These are kind of working the other direction. We're going to put this in summation notation form. So we've got something like this. We're going to just do a couple of these guys. This is k equals 1 up to, because this is infinite, it's going to be up to n. And then all we have in here is a formula that represents how we generate these terms. So this might take a little bit of thought. You could always go right to just filling in the blanks of our a sub n formula here. A sub n equals 2 plus n minus 1 times 2. And if you simplify that, you'll have your expression. I don't know that we need to do this. Some of you could probably just tell me the expression that goes right here is 2n. But if you don't see that, we've got a sub n equals the first term 2 plus n minus 1 times the difference, 2. I'm just using the formula from the last section. And then I'm going to simplify this. Well, guess what that simplifies to? 2n, right? So if it's infinite, you'll have I equals 1 or k equals 1 or whatever, some kind of counter down there, up to some variable, okay, if it's infinite. So we've got a variable n up here, okay? And then the expression will be a simplified version of the a sub n arithmetic sequence formula. Here we've got summation from k equals 1 to, we've got to figure out what term that is, and then we'll have it. So we've got to figure out what term this is before we can do it. So we've got a sub n, which is 305, equals the first term, 125, plus n minus 1 times the difference it looks like is 15. So if you could solve that for n, then we'll know what to place up here. So 305 minus 125, divide by 15, add 1.
I'm working there.
180 divided by 15. Okay, so we're going to go k equals 1 to 13. And then our expression is a sub n equals first term 125 plus n minus 1 times 15. This is hard to write on here. This thing is crazy. So we got 125 plus 15n minus 15. If I simplify that, I end up with 15n plus 110. So the 15n plus 110 is my linear equation in the form mx plus b, right, that generates the terms of the series. So you can just go back if you can't come up with the equation just by looking at it. I mean, it works like this. If this is the first term right here, and the difference is 15, you've got to go back 15 to get the y-intercept, right, the b. So you go back 15. It's like if this is first term, the back 15 would be the 0th term or the y-intercept, right? That's where the 110 comes from. And then the 15 is the difference, and the common difference is like the slope. So you could probably look at it and figure it out based on your knowledge of linear functions. So arithmetic series notation. And this sigma notation, or summation, I keep calling it sigma, it is sigma, is very important. We're going to use that to define the integral in calculus seconds. So,
What period is calculus?
I don't know. No. All right, see if you remember what we talked about earlier here. This second one on here, the n equals 1 to 56. How many terms do we have here?
57.
No? 56, yeah. There it is. Crazy writing. 56. What about here? What's this going to be? If I started at 0 and went to 20, how many would I have? Yeah, you'd go 20 minus 0 plus 1. So 20 minus 0 and then plus 1. So we'd have 21. What about here if I went from 12 to 98?
97.
12 to 98. 12 to 98. You find the difference between 12 and 98 and add 1. What is it? 98 minus 12 is, yeah, so that's 86, and then plus 1, so 87 terms. So that's 87 terms. Let me show you, okay, so this one right here, I think we're okay with this one. If you wanted to find the sum on this one, both of these I'd like you to do with the calculator. Let's talk about what that would look like on the calculator. The first one here, we're going 3n minus 8. Okay, so here we go. Here we go. So if you have your sum sequence all the way already up, you can hit second enter, recall it. Well, maybe not. Second enter, let's see if it'll recall. There it is. And then you can go back and alter it if you'd like. But that first one there, let's go back over here to the arithmetic series, is 3n minus 8 is the expression. So I'm going to change this to 3n minus 8 with respect to the variable n, starting at 1 and going up to 40. So that's what that notation means, is it says find the sum of the arithmetic sequence defined by 3n minus 8 from the first term up to the 40th term. Hit enter. So that first one would be 2140. Just using the calculator, 2140. And then the second one goes from n equals 6 to 14. So what would change on my calculator entry here? If I hit second and enter, I can recall that line. What's going to change here? 3 minus 1/2 n, and we go from 6 to 14. 3 minus 1/2 n. So how about if I type in 3 minus 0.5. Oh, if you want to insert something in, hit second and the delete key, and it will allow you to enter in a variable. So that would be 3 minus 1/2 n or 3 minus 0.5 n. And then what needs to change here? It's like I'm going from 6 to, is it 20 this time? 14? I don't remember. Yeah, 6 to 14. And just by a step of 1. And then hit enter. So I like you to use the sum sequence on there, unless, I mean, you can add it up just one at a time, and you just have to generate the number, keep hitting plus signs. On the calculator, what you can do is, let's see, what would the first term of this second one be? Or if you plug in 6, 3 minus 1/2 times 6, oh, that's 0. So it'd be 0, and then you keep subtracting. Next one would be 3 minus 1/2 times 7. Should be negative 1/2. So the way it would work is this, calculator. You'd have 0, and you hit enter, and then minus 0.5 or 1/2, and then enter, and then minus 0.5, enter, keep going. That would generate the terms. Then you got to add all those terms up. So you have to add up 0 plus negative 0.5 plus 0.1 plus negative 1 plus negative 1.5, and those add up to negative 18. But I'd encourage you to use the calculator. Use that sum sequence. All right, can you just look at these and tell me which two up here are arithmetic?
The ones that aren't in squares, so like the first two.
Yeah, the first two, the ones that don't have a variable power cap. And the other ones, do you know what these are? These are the 4?
Geometric.
They are geometric. We're going to talk about those next time. They are geometric. The only two that are arithmetic are these two. The common D here on the first one would be 2, and the second one would be negative 4. So we've got two arithmetic ones. I'm gonna mess up here. It's all D equals 2. I can't write on here anymore, so we'll just say it verbally. So D equals 2. And then the second one here is arithmetic. D equals negative 4. And then if you could just write, well, you can wait if you want, but the rest are geometric. Or you can wait. The only two that are arithmetic are those first two. All right. We've got a little bit of time today to try some of these in your groups. So if you could move into groups here, grab a book. Yeah, I'd like to do it now. We got just a little less than half an hour.